Hi, my name is John. Welcome to part 2 of the Sun and Night Nightcap. What I want to do on this little short video, I want to finish off the adapter for the tailstock DTI holder. It'll be all lathe work, a little bit of milling work. I'm going to give the lathe a quick clean down. You don't see me wear gloves very often. I wear gloves for welding. And I do wear gloves when I'm cleaning machinery down. I wear thick nitrile gloves. These are really strong ones, just for picking up chips like that, because they're sharp, they'll stick in your fingers. If you give the lathe a quick clean down in between jobs, you find that it's much pleasanter to work on. It's also a lot safer. And then depends how much I'm using the lathe, but normally once a week I'll give it a good clean down and a lubricate. That's a piece of metal machine square in the last video. All that does is it'll be clamped onto the barrel like that, and then as the drill's wound in, the clock gauge will measure accurately the depth of cut. So all I want to do, I want to work out where I want to be hole in here. Obviously this is going to be able to pivot. So all I want is enough metal so the pin of the DTI is touching. What I'll do, I'll put a mark on with a Sharpie where I want it. Just draw around it, now I can accurately mark it. Right, what I need a hole in the centre of there. The size of the barrel of the tailstock, and then we can split it, use a slit and saw, and I'll drill and tap it for a clamp hole so it clamps onto there. I'm going to mark it out on the surface table with a height gauge. I don't need to, I've just got a surface table and a height gauge, and I haven't should have been used. This surface table I got given, a friend gave us it. He actually found it in the bottom of an old cellar, and he's got a big grinder at work. He reground it for us. We'll give it a quick clean. Quick wipe with just brake cleaner, because it's always put away with a nice coat of oil on it. It's an old English one, it's a proper one, it's really heavy. I bought a digital height gauge. It's quite a big one, but seeing that, most of the things I do, I build models are always big models. Downstairs touching the table and 0 the clock. We'll do it in metric, 0 millimeters. We'll measure the height of it. .07, which is, to all intents and purposes, 51 millimeters. Half that's 25.5. So take that down to 25. You tighten the top one up and adjust on the bottom one. You can get it absolutely spot on. 25.5. Tighten that one up, and all you would do, you'd just put a light scratch. If you turn it over and scratch from the other side, it's leaving one line, which proves that you've actually halved it. Right, we want to go in 25 from the bottom as well, so we can tweak that to 25. 25 and a half will do it. We might as well make it 25. So you've got like a vernier adjustment. 25. Put another mark across there. Now I've done the scribe marks inside the circle I want to cut. I haven't gone right across. I don't want to leave a mark on it. What I want now, I want a nice pop mark on there, and then we'll mount it in the 4-jaw chuck and bore the hole. Once I've finished using the surface plate, give it a spray with rust preventer. I don't get any problems at all with damp in here. That's just left to dry. I also have a piece of wood that I put on top of the surface plate to protect it. That lives there. I wear really strong glasses for close-up work like this. So what I will do, I'll put the punch on one line and move it up on the other line like that, and give it a really gentle tap. And that's nice. If it's slightly off, you can angle the punch and move it one way or the other. It's one thing I keep going on about. Just protect the bed of the lathe when you're changing the chuck. This chuck shouldn't be that tight. It's got a spindle lock on it, and here's the spindle lock. Any tighter than that, any more force than that to loosen it, and I'll put a bit of hexi bar in and use a bigger spanner. Here I keep saying you can drop the chuck and you won't hurt anything. This lathe's got some marks on the bed. It's an ex-school lathe. None of the marks have been put on by me. One of the worst things is a hacksaw. You go through with a hacksaw. That's a really important part of the lathe, the register that the chuck fits on. If that's not clean, or if that gets damaged, you'll lose the accuracy of the lathe. The 4-jaw chuck. I've got a couple of 4-jaw chucks. This is the best one. You make sure the register's clean. Now as normal, a few drops of oil, just engine oil, just 1040, nothing fantastic. If the chuck doesn't screw on as easy as that, you're doing something wrong. Just a nip, that's all it takes. The chuck will tighten on as you're machining anyway. Compressed air is a handy tool for cleaning out chuck screws and whatnot, but make sure you wear safety glasses. When we're setting this up, the hole we want is the same diameter as the lathe tailstock, spindle or barrel, which is smaller than that, so we can mount the job flat on the face of the chuck. What I'll do, I'll fetch a centre in and I'll hold it there and then show you how I mount it up. Obviously we can't just tighten the chuck up onto the soft aluminium because it'll mark it. Putting in. What you can do, you can use this lathe steady, lathe centre to hold it up against the chuck back plate. So that's in the centre punch mark, that's held flat up against the face of the chuck. To stop marking it, some soft packing pieces, little pieces of aluminium. Try and hold that in so you can see. And just snug each jaw down onto it in turn. It's good when you've got the centre to hold the workpiece, it doesn't fall about. It's different when you can't do that. What you can do, you can fasten the pieces of aluminium on with insulating tape or rubber bands. I could turn the chuck jaws round and get a better hold of this, get a hold of the full depth of it, but it's only aluminium. I'm only putting a hole through it. There's no heavy machining going to be done. Just nip each one up. I've got two chuck keys, a big one, a little one, a tiny one. Using a clock gauge for setting things running through. What I can do, if I needed it really 100% accurate, I can put what I call a wiggle bar in. That goes in there, and it goes into your centre. It's spring loaded. Put a clock gauge on there like that, on centre height. We've got a clock gauge mounted on centre height. The closer you get to the chuck, the more accurate it's going to be. And set was 0. It's within 1 thou. Within 1 thou before I adjust it. And that's, to all intents and purposes, running dead true. So basically, using the centre pop mark in the centre in the tailstock gets you very accurate. Centre drill mark. I'm drilling a couple of stages. The 6mm drill first. The 12mm drill. So the drill's putting even shavings out each side because the drill's sharp properly. 19mm drill, and then we'll bore at the sides from there. And we'll put our boring tool on, a boring bar. We'll make sure there's plenty of clearance between our chuck jaws and our carriage, and we'll lock off our stop, which means we won't go too far, just enough to bore it. Right, we'll take a light cut. We've got it set up so we've got enough travel to go through the job, but there's going to be no contact with the chuck jaws on the tool post or the carriage. Touch it off, 0 our cross slide, and put a 20 thou cut on. Just to clean it up, then we can measure it. 90. So what, another 50? Another 100, sorry. Should be getting here. What are the 115, 120? I want 160. Put a 15 thou cut on. Just feeding this in by hand. That's pretty good. Goes in, I can actually feel it rubbing. Right, we'll take it out and give it a try for real. And that's nice. That's just the sort of fit I want. It's got a little bit of slop on, but not too much. And when that's clamped on there, and my clock gauge goes on there like that, that'll be clamped, and that goes over a direct reading in thousandths of an inch, or metric if you put a metric clock on. Anyway, thanks for watching, thanks for subscribing.